Jai Jayendra, Namaste and welcome to my channel. Today we are going to solve the 56th question of the problem solving series and the fourth and the last question of heap data structure. The difficulty level for this question is hard and this question has been asked in Google, Facebook, Amazon, Microsoft and multiple companies. So find median from data stream. So we have data coming together like continuously and we need to implement a class median finder which finds the median any point of time whenever the there's an input that okay now give me a median of the all the data that has come. Okay, let's look at the example and then we will understand. So we have to implement this class median finder. So this median finder class is called and then add number is called. Okay, so what is the number that is being added here? 1. Okay, so in our stream 1 has come. Okay, then which number has been added? 2. So then 2 has been added, 2 has come. Now they call this find median. So we need to give the median of these two values. What is the median? Median is the middlemost element of a numbers list of numbers which are arranged in the sorted ascending order. Okay, so mean median mode you have studied before. So we need to find the median. So you know the formula for the median, that when there are odd number of elements, then the median is the n plus 1 divided by 2 number of index in the list of elements when it is arranged in ascending order. But when the numbers are even, like in this case, so we take the middlemost value, like whatever is the middlemost numbers, we take the average of those two values. Like here there are two numbers, so when we need to find the median, so these two numbers, this is not even number, so we'll take the average of this 1 plus 2 by 2. Okay, that is 1.5. So here we will when this is called we return nothing, this is called we return nothing, this is called we return nothing. When add num find median find add num is called we return nothing, but when we get this find median call, we will return the median, and the median of 1 and 2 is 1.5. Okay, since there are even number of elements in the list of the data stream, like the data stream list, then again add num is called, so 3 is called, and then find median. So find median, now we have 3 elements. This is an odd number of elements, so n plus 1, 3 plus 1 is 4, 4 divided by 2, the second element. So what is the second element? This is the middlemost element, 1, 2, 3, so this is the middle element, and so we return 2. Okay, so this is our answer. Now how do we solve this? So what do you understand from this example? We need to find the median and elements are coming together. Here in this case the elements have come in an ascending order. So if it was just the ascending order, we would have to do nothing but just calculate, see if we'll take the number in a vector and we will see what is the middlemost value. We'll find that you'll just use the median formula and we'll calculate in order of 1, and we'll this could be solved in order of 1, and the traversal of the data stream order of n, so by order of n it could be solved. But this is not given that the elements of the data streams, the numbers are coming in an ascending order. It could be any order, like there is no guarantee. So to find the median we need to sort it, and the sorting would take order of n log n. So sort it every time and then again find the median using the formula. So the time complexity is too much, n log n into finding the median, and every time n log n into n, the number of data that have come. So the time complexity would be n square log n, something like that. So we need to optimize it. How can we solve this now? So heap, we are studying heap. Can we use heap? What heap does, you know, right? We have min heap, which gives the minimum number every time from the list, and we have max heap, which gives the maximum number every element in the list. Now how can we solve this problem using mean heap or max heap or both? So let's think of an example. So let's see here. Let's get the intuition of the solution and then we will code it. Okay. So if the elements say in the data stream are like coming as 5, 4, 7, 6, 9, 8, 2, 3, like this, we have a list of data that have come. Okay, this is a data, right? So if we have max heap, say, okay, M1 and M2, whatever the elements comes in the beginning, we enter it in the max heap, 5. Okay, then next element comes, we enter it in the max heap. We will try to keep the difference. If the difference between the max heap and the mean heap is greater than 2, then we will change. We will enter the max heaps. If max heap is bigger, then we will enter the max heap top to the mean heap, so that we'll try to keep the numbers same in the max heap and the mean heap, so that if we take the average of the top of their elements, then we get the median value, right? So that would be our approach. You'll understand when we solve this example. So when 5 has come, we don't have any problem. But when 4 has come and the mean heap, this is the max heap, okay, max heap, and this is the mean heap, okay. So we don't have any problem when 4 has come, because the size is actually, the difference is less than 2. But when 7 comes, right? So initially we enter it inside the max heap, okay. But now you see that the difference is greater than 2 between the size of the max heap and the mean heap. So what do we do? So 5, 4, 7, when it comes, 7 will come in the top of the max heap, and then we will move this 7 to the minimum heap, okay, because the difference was more. Okay, now 7, 5, 4 is there, and this 7 would be eliminated from the max heap. You'll understand how this will solve our problem. Now when 6 comes, okay, and then 6 is inserted here, and 6 will come in the top because 6 is greater than 5 and 4. Now the top element of the max heap, is it greater than the top element of mean heap? No. So now when we take out the average of 4, 5, 6, 7, we know that this M1 size is more. So we will give 6 as the median. But if it would have been equal, the size of the M1 and M2 if it would have been equal, we wanted that point of time to take the average of this. Like we have taken the average of 1, 2. Right? That way we need to solve this problem. Okay. So you'll understand what is the intuition. You'll understand how to optimize this, right? We don't need to short it every time. With this two one max heap and one mean heap, we can solve this problem without shorting and in a order of log n approach. Okay. So now 9 comes. So 9 will be inserted in the max heap first. Then we will check. Okay, 9 has been inserted, and both of them are not empty. So the top of the max heap, is it greater than the top of the mean heap? Yes, it is greater, but we don't want that. The top of the max heap should not be greater than the top of the mean heap. If it is greater than the top of the mean heap, then we will move the top of the max heap inside the mean heap. Okay, that is the logic, so that the values in the top of the max and the mean heap are very close to each other, and they are the middlemost value. So here when 9 comes, this 9 will be moved to mean heap, and this will come over here. Okay, not here. It would come over here because it is a mean heap. Okay, so 6 and 7 are the closest middlemost values in this data stream for 4, 5, 6, 7, 9. Though when we are asked to find the data stream or find the median, this 6 would be returned because the size of the M1 is greater. So we will return 6 in this case. When 8 comes, 8 again comes over here. Okay, and now 8, 6, 5, 4 is the list in the M1, and 7, 9. So the top of the M1 is actually greater than the top of the M2, that is mean heap, right? So again we will move this 8 over here. So it will become 7, 8, 9. So our mean heap is 6, 5 and 4, and our max heap is 6, 5, 4, our mean heap is 7, 8, 9. So if you were asked to find the data, median of this data string up to here, then what you would have said, okay, the numbers are even, so we will find the n plus 1 by 2. So 0, 1, 2, 3, 4, 5, 6. 6 plus 1 is 7. 7 by 2 is 3.5. So that means the third value, right? So third value is 7. No, since it is even, so we will find the median. It's not odd. So the median would be n by 2th and the n plus 1 by 2th average. So n by 2 is 6 by 2 is 3. 1, 2, 3. This one 7. Okay, and then n plus n by 2 plus 1 is 6. So 6 is 7 plus 6 by 2. So it would have been 13.5, that is 6.5. Similarly here, when the size is equal, we will take the middle average of the top of M1 and top of M2, that is 6.5. So in this way, we did not short it, we just maintained these two mean and max heaps order, and then we solved it, and any time we can solve the median using this in order of 1. This will be given, this function will be resolved in order of 1, but this add num we will use this priority queues order, and we will be resolving in where the number should go, either in the max heap or the min heap, and then internally max and min heap will take order of log n, that is another thing, but our solution will be optimized. Okay, let's code it. So we take a this is a constructor, we take a priority queue. Okay, we take a mean heap. Okay, so we take a mean heap and we name it as max. Why? Because we are actually we take a we will name this is a mean heap. We will name it as max because we are giving it the maximum value. The maximum value is going to the mean heap. Okay, so though it is a mean heap, I am naming it as max. Okay, and then we declare a priority queue. This is a mean heap, and then int vector of int greater int, and this is mean. Okay, and this mean is actually a max heap, but it will contain the minimum values, right? The smaller values. Okay, so that we can maintain the order. So add num, what we'll do, we will push the element to the max heap. Okay, this is max heap. Okay, in the max heap we will push the okay, so in the mean heap we will push the element. Okay, yeah, in the mean heap we will priority queue. So this is a max heap, it should be named as mean, and this is a mean heap, which should be named as max. Okay, and we will push always to the max heap. Okay, now when we have pushed it to the max heap, the value, now what do? We will check if mean dot size is not equal to 0 and max dot size is not equal to 0, and mean dot top is actually, if it is greater than, if mean dot top is greater than max dot top, that means if the max heap's values, the top value of the max heap, it is greater than the top value of mean heap, we need to equivalent it. Okay, so what we will do, we will max dot push the mean dot top value, the thing that we did in this example. Okay, and then we will pop out the max value from the minimum. Okay, and so if mean dot size is greater than max dot size plus 1, so if there is a difference of 2, say if every time 6, 5, 4 smaller elements are coming, right, 6, 5, 4, 3, 2, so we are entering it in the mean heap, okay, every time. But if the difference is greater than 2, the size difference is greater than 2, we have to move the top elements of the the max heap to the mean heap. Okay, so what will be if this is the case? If it is greater than this, then same, max dot push is equal to mean dot top and then mean dot pop. Okay, else if max dot size is greater than mean dot size plus 1, then we will do the same thing. We need to move mean dot push, max dot top, and then max dot pop, so that the sizes are equal to each other, and we can, if when the number are even, then we can just take the average of the means top and the max top. Okay, so in this way the add number function will be completed, and the find median will be the simple. If it is odd, so I'll just write it. If odd, then take the top of greater size heap. Okay, else what you return, if it is else, if even, then return mean dot top plus max dot top divided by 2, middlemost value. So in this way we can solve this, optimize this problem. I hope the explanation is clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. But do come to my code walkthrough section to understand and to see how we have solved this problem. Okay? Yeah. Here is the code walkthrough of the 56th question and the fourth and the last question of the heap data structure. Find median from data stream. This is in the LeetCode platform. You can see the questions that the companies that have asked these questions are a lot of companies: Amazon, Facebook, Microsoft, okay, Google, Oracle, Apple. Okay, so we have already discussed the example, the same example. So let's look at the solution. So we have taken the mean heap and the max heap here. We have named it as max array, the mean heap, because this mean heap will contain the maximum values, the maximums, and this mean, the max heap we have named as mean array, because this array will this priority queue will contain the minimum values of the list, so that when we you know the logic, right? So when we have to get the median, we can take the top of both the elements and then can find the median, or otherwise whichever elements are more in the list, we can get the top of that element. Okay, so we in the beginning we insert the element to the max heap, and then we see this condition: if the max heap's top element is greater than the mean heap's top element, then we move the max heap's top element to the mean heap, and if the difference is greater than 2 for both of them, we moves with the top of the element to the other heap, because we don't want the difference to be greater than 2. it could be equal, the difference could be greater than 1, but if it is greater than 2 we don't want that, so that we get the middlemost value every time. This helps us to get the middlemost value, this logic and the um mathematics. And when we are asked to find the median anytime, we use the same logic. If the size of the mean array is greater, then we return the mean array stop, that means the max heap stop. And if the size of the mean heap is greater, that is the max array, then we return the max array stops. And if the sizes are equal, we return the average of the max array, max heap and the mean heaps topmost value. Okay, because that is only accessible in order of 1. So this find median is solved in order of 1, and this add num is solved in order of log n. Okay, so let's run this. You can see the test case has passed, and we'll submit this. So this has been accepted. You can see the code, I can understand it. I hope the explanation is clear, and see you all soon in the next video, where I start a new topic, that is recursion, the 57th question of the problem solving series.